Hi everyone. Here's some examples of molar volume questions. There's three. Here's the first one. How many moles of oxygen are present in 5.6 liters at SATP? Like I've said before, if you feel comfortable, you can just dive right into this question. If you feel okay with the formula, what's being given to you, what you're being asked to do, you might find yourself diving right in. However, sometimes it's worth it just to slow down. This says, how many moles of oxygen are present? So how many moles? We're looking for N. We have the volume, 5.6 liters. That's the volume. Reminder, to work with molar volume, the volume itself has to be in liters. This is already in liters. We don't have to do a unit conversion. The question does specify SATP. That means we're going to use the molar volume (24.8 liters per mole). Questions about molar volume are always going to specify whether we have SATP or STP conditions. Just look at these three questions. SATP, STP, STP. That has to be included every time so we know which version of the molar volume to use. Maybe now we're at a place where we can move forward and dive right in. There's nothing wrong with writing the formula down though as well. So we have moles is the volume divided by the molar volume. So here we have the volume, 5.6 liters over our 24.8. liters per mole. Again, this is going to work the same for all gases. Because this is oxygen in this question, that does not make a difference. This could have been nitrogen, carbon dioxide, ammonia. Any gas would behave the same way at SATP. So we just have one little division to do. It's not going to take that long. 5.6 divided by 24.8. That's 0.225806, etc. But this is my raw answer. I need to finish it off by thinking about significant digits and units. There's only one number in the question, 5.6. That's two significant digits, so I need to round this off. 0.23, and we found the moles. 0.23 moles, our final answer. A second question. Determine the volume of 0.115 moles of carbon dioxide at STP. Again, we might be in a place now to dive right in, but labeling, nothing wrong with that either. Determine the volume. Let's find the volume. We have 0.115 moles. That's the N. This time, it's STP. The molar volume at STP is 22.4 liters per mole. Now maybe I move forward. However, I might want to put the formula down. Here we have moles, volume over molar volume. But to solve for the volume, which this question asks us to do, the volume is the moles multiplied by the molar volume. Let's do that. So we have our N, that's the moles, 0.115 moles, multiplied by the molar volume at STP, 22.4. We're going to do 0.115 times 22.4. 0.115 times 22.4. It's 2.576. Once more, this is our raw answer. We need to finish it off by thinking about significant digits and units. The one number in the question has 3 sig digs. I'm going to round that off. 2.58, and this was the volume. You can see here the moles are going to cancel. That leaves us liters, or when we're working with molar volume, the volume is always going to be liters. A third example opens the door to the possibility of a two-step problem. Because this formula, moles is volume over molar volume, because it has a moles in it, there's a connection with our earlier work on mass and molar mass. Let's look at this question. Calculate the volume of 50 grams of nitrogen gas at STP. Again, even though it's a two-step problem, your comfort level might be in a place where you can just move forward. However, we can just slow down. Calculate the volume. We're looking for the volume, V with a question mark. 50.0 grams. Ooh, that's the mass. That's M. We need to really be conscious of the important difference between grams and moles. 50 grams of nitrogen gas. That's going to make a difference now. And we have STP, just like we did before. The molar volume at STP is 22.4. Again, no matter what, when we're working with molar volume, the question has to tell us SATP or STP. This capital V in our formulas, it's either going to be 24.8 or 22.4. And the question's going to tell us which version to use. Here, as I think about what I have to do, we have this formula over here. V equals the moles times the molar volume, but we don't have the moles. So what we're going to need to do is calculate the moles by doing mass over molar mass. And then we'll take our answer and use it in the molar volume formula. So mass over molar mass first. The moles, it's the mass. We have 50 grams. 50.0 grams. Now, because this is a two-step problem, now the gas matters. It's nitrogen gas. The formula for nitrogen gas is N2. We might accidentally just put one N, but we need to have the correct formula to get the molar mass. N2, 2 atoms of nitrogen, each with an atomic mass of 14.01, means the molar mass is 28.02 grams per mole. And I can do this calculation. 50 divided by 28.02 is 1.784439,686. I'm not going to round off right now. I'm just keeping that number on my calculator screen, and I'm going to carry my answer into the other formula. The volume is the moles, this answer. These moles right here, I'm carrying that answer forward, and now we're going to multiply by the molar volume, 22.4. That number is still just sitting on my calculator, so now I'm just multiplying by 22.4. It's 39,971,44897. This is now my raw answer. I go back to the question. It only has one number, 50.0 grams. That's 3 significant digits. So I have 39.971, which I need to round off, so it has 3 digits. It's 40.0. This was the volume, liters. When we're working through problems involving molar volume, the main thing to be on the lookout for is it STP or SATP? We have the chance to do one-step problems if we have only moles and volume. However, as soon as mass shows up, we're going to have to do two steps. Here, we started with the mass, which we converted into moles first, and then did our second step using our new formula where we multiplied by 22.4. Like always, every question we have to do our best to satisfy the demands of significant digits, and we need to show the units as well. And I hope that helps.